Ever wondered where the metal parts in your car, your phone, your tools come from? Let's unravel this mystery together. Consider this, the birthplace of metals. The origins of metals like iron, copper, aluminum, and nickel trace back to raw forms buried deep within the earth. Mother Nature, in her infinite wisdom, has been crafting these hidden treasures for millions of years. These raw forms, known as ores, are the starting point of our journey. From the dense rainforests of Brazil to the vast deserts of Australia, these ores are mined from diverse locations around the world. It's a complex process that involves extracting them from the earth, then processing and refining them to produce the metals we use daily. These metals, in their pristine form, are the raw materials that fuel our technology, our infrastructure, and our daily lives. So that's where our journey begins, deep within the earth where these precious metals are hidden. Now, how do we get from a chunk of rock to a usable metal? Well, it's a fascinating journey, let me tell you. The process of extracting metals from ores is not for the faint of heart. It's a multi-step process that involves a lot of hard work and science. First off, the ore needs to be crushed. This isn't just a quick smash and grab job, the ore is meticulously crushed into a fine powder. This makes it easier to separate the valuable metals from the less valuable rock. It's a bit like looking for a needle in a haystack, but in this case, the needle is a precious metal, and the haystack is a pile of rock dust. Next comes the grinding. The finely crushed ore is ground even further until it's almost as fine as flour. This step helps to increase the surface area of the ore, which makes the next steps of the process more effective. Once the ore is adequately crushed and ground, it's time for the smelting process. This involves the use of heat and chemicals to coax the metal out of its rocky prison. The ore is heated to incredibly high temperatures in a furnace, and then chemicals are added. These chemicals react with the metal in the ore, causing it to separate from the other elements. The result of the smelting process is a molten mixture of metals and slag, a byproduct of the smelting process. This mixture is then poured into molds and allowed to cool and harden. The metal, now free from the rock, forms into what we call ingots. These ingots are essentially big bars of pure metal. They're a far cry from the chunk of rock we started with, but they're still not quite ready to be turned into the metal parts that make up our everyday items. The metal has now been liberated from its ore and is ready for the next stage. We've come a long way, but the journey from ore to metal is just the beginning. The real magic happens when these ingots are transformed through the art of metal forging, but that's a story for another scene. So we have our metal, but how do we shape it into something useful? That's where the magic of metal forging comes into play. Metal forging, in its simplest form, is a manufacturing process where metal is pressed, pounded or squeezed under great pressure. Now you might be wondering why we go through all this trouble. The reason is pretty straightforward: to produce high-strength parts. Think about it. The metal that comes out of the Earth's crust isn't exactly ready to be used in a sports car or a skyscraper. It needs to be shaped, molded, and strengthened. And that's exactly what forging does. It transforms raw metal into a work of art that's as strong as it is beautiful. So in essence, metal forging is a bit like baking. You start with simple ingredients, but with the right pressure and heat, you end up with something incredible. With that, we are ready to dive into the fascinating process of metal forging. Are you ready to see how a piece of metal transforms into a useful part? We're about to dive into the fascinating process of metal forging, where raw metal is molded into a robust, practical part. The first step in the forging process is heating. This involves raising the temperature of the metal to a point where it's easier to shape. The heating process is crucial, as it ensures the metal becomes malleable without melting. Different metals require different temperatures, but typically, steel is heated to about 2,300 degrees Fahrenheit. That's hotter than molten lava. Once the metal is glowing hot and ready to be shaped, we move on to the molding stage. This is where the real transformation happens. The heated metal is placed on a die, which is essentially a mold that gives the metal its shape. The metal is then hammered or pressed into the die. This process is repeated until the metal takes on the desired shape. It might sound simple, but the precision and skill required to mold the metal perfectly cannot be understated. Now let's talk about the different types of forging. There's open die forging, where the metal isn't confined by the die. This method is often used when creating large and simple parts. On the other hand, we have impression die forging. Here, the metal is placed in a die that has a pre-cut profile of the desired shape. The metal is then compressed until it fills the die cavity. This method is perfect for creating intricate designs with high precision. Another popular method is seamless rolled ring forging. This process involves piercing a hole in the center of a round piece of metal and then rolling it into a thin ring. The result is a strong, seamless ring that's often used in applications like jet engines, windmills, and large industrial equipment. After the metal has been shaped, it's time for finishing. This step involves trimming the excess metal and smoothing out any rough edges. Sometimes a second heat treatment is applied to strengthen the metal further. The finishing process ensures the forged part not only looks good, but also functions as it should. The final step in the forging process is cooling. The forged part is left to cool down, either slowly in the air or more quickly in water or oil. This step solidifies the shape and locks in the strength of the part. And voila, the metal has been forged into a useful part. This intricate process, which combines heat, force, and precision, creates some of the strongest and most durable parts in existence. From the engine parts in your car to the utensils in your kitchen, the art of forging is all around us, shaping our world one piece of metal at a time. Why go through all this trouble to forge metals, I hear you ask? Well, let's dive into the compelling reasons behind this ancient practice. Firstly, metal forging significantly enhances the metal's structural integrity. By heating and deforming the metal, the forging process aligns its grain structure, resulting in a final product that boasts superior integrity compared to metals shaped using other methods. Secondly, there's strength. And we're not talking about the kind you get from a morning cup of coffee. Forged metals are inherently stronger than their cast or machined counterparts. This increased strength means that forged components are less likely to fail under stress or pressure, a critical advantage in industries where component failure can lead to catastrophic results. Additionally, metal forging allows for the creation of parts that can withstand high pressure and stress. From the pistons in your car's engine to the gears in a massive cargo ship, these high-strength components are integral to the functioning of many machines we rely on daily. It's also worth noting that the forging process allows for a high degree of control over the finished product's shape and size. This precision further enhances the versatility of forged components, making them an ideal choice for a wide range of applications. So when you consider the improved structural integrity, increased strength, and ability to withstand high pressure and stress, it's clear that metal forging is far from an outdated method. In short, forging makes metals stronger and more reliable. From the earth to your hands, it's quite a journey, isn't it? Picture a deep, dark mine where the story begins. Here, the precious ore is extracted, a raw, unrefined piece of the earth, destined for greatness. It's hard to believe, looking at this rough, rock-like material, that it will soon be transformed into a shiny, strong, and useful part. The ore then embarks on a transformative journey. It's processed, refined, and purified, shedding its rough exterior to reveal the pure metal within. It's as if the ore is undergoing a metamorphosis, leaving behind its humble beginnings to become something much more. But the journey doesn't end there. The metal, now pure and shiny, is not yet strong. It's still soft, malleable, and waiting for its final transformation. And that's where the magic of forging comes in. Through heat and pressure, the metal is shaped, hardened, and strengthened. It's a process that's as much an art as it is a science. Each strike of the hammer, each blast of the furnace serves to forge the metal into a part that's strong, durable, and ready for use. In the end, what was once a humble piece of ore has been transformed into a part that's strong, useful, and ready to serve its purpose. Next time you see a metal part, remember the incredible journey it's been on. From deep within the earth to the forge, it's a process as old as civilization itself.